Hello, this is Mrs. Arnold, and today we are going to do a lesson on calculating pin numbers in chemistry. This lesson falls under standard number 4, which is atomic structure, and it states that the student will understand that the properties of matter and their interactions are a consequence of the structure and arrangement of the atoms. In this lesson, we will have two objectives. The first thing students should be able to do is use the atomic number and the mass number to calculate the number of protons, electrons, and neutrons in any element. And then we are going to take that information and illustrate the structure of an atom by drawing a Bohr model. So we're going to start off with writing some symbols. In this dark navy circle, we have kind of a generic symbol that we're going to use. That X is going to be our symbol, the actual symbol of the element. And then we have to have two pieces of information attached to that symbol. The first one is the atomic number, and the second piece of information is the mass number. Now in our top upper right hand corner, we've got two elements here. One is gold, the second one is carbon, and these are what you would typically see on any periodic table. And so our first one we're going to start with is gold. I can see that the symbol for gold is AU, so I'm going to write that down. And now I've got two numbers I can choose from. When I am looking at this atomic number, I'm looking for the whole number. So I'm looking for no decimals. So I'm looking at this number 79. This is going to be our atomic number for gold. So that is going to be written at the bottom. Now I have this long decimal number, and when it's a decimal, it's not that good to me, so I want to round that off to a whole number. And I'm going to use those typical rounding rules that we've learned in math. So I'm going to look at that number after the decimal place. Is it 5 or greater? It is. 9 is greater than 5. So I'm going to round this number up to the next whole number. So 196 rounds up to 197. And this is going to be my symbol for gold. Moving on to carbon, I see that carbon's symbol is C. And again, I've got those two numbers to choose from. I'm going to pick that whole number. That's going to be my atomic number. So that goes at the bottom. So carbon's atomic number is 6. And then I have that long decimal number that I need to round off. So I'm going to look at that number after the decimal point. This time it's a 0. So 0 is less than 5. And so that means I do not have to do anything to that number. I'm going to keep it the same. So carbon's mass number is going to be 12. So being able to write the symbol is going to take us to our next step, which is calculating the pin. Now, these pin numbers, not a pin like in an ATM, this is going to be the number of protons, electrons, and neutrons that an element has. We see our cute little periodic table square up here. Looks like a little banana peel because potassium is found in bananas. And we have our symbol is K, which we already have written here. Now I've got two blanks, a bottom one and a top one. So remember the bottom one, I'm always looking for that atomic number, the whole number. So I can see that it is 19, so that is going to be written at the bottom. And I'm going to round off that mass number, so 39.0 is going to stay at 39. So I've written my symbol. Now I'm going to calculate the protons, electrons, and neutrons. Protons very easily is going to be equal to the atomic number. So my bottom number is 19, so that means I have 19 protons inside an atom of potassium. For electrons, it says electrons are going to be equal to the number of protons. So whatever protons are, electrons are going to be that same number. So protons are 19, electrons are 19. Now probably the most difficult one is these neutrons, and it's really not that difficult at all. All I am going to do is take that mass number and subtract the atomic number, and that will give me the number of neutrons. So if I look at my mass number 39 and I subtract my atomic number of 19, when I do that math, I get a number of 20. So I have 20 neutrons in potassium. So a couple more examples of calculating pins. Now, if you notice, I've got three elements here, all start with the letter C. Now, when searching for these on the periodic table, it might be a good idea to start looking for those C symbols, but not always do the symbol and the name match up. So be careful when you're looking for those symbols that they match up correctly. So we're starting with chlorine, okay? That's our first square up here. Again, we're writing our symbol, which is Cl. Atomic number is going at the bottom, so I look, that's my whole number, 17, going at the bottom. And then I'm going to round off that mass number, so 35.4 is going to stay the same, so it rounds to 35. Okay, moving on to chromium. Chromium, its symbol is Cr. It has an atomic number of 24, so that goes at the bottom. And I'm going to round off that mass number, so it rounds to 52. And my last one, cesium, okay, its symbol is Cs, so I'm writing my Cs. My atomic number is 55, that goes at the bottom. And my mass number, again, I'm rounding it off, so it rounds to 133. Okay, so this should be our first step when calculating the pin. Okay, now I'm going to look at protons, and we're going to do all of chlorines first. So if I look at protons, I remember back, I know that protons is equal to that atomic number. Okay, and my atomic number for chlorine is 17, so it has 17 protons. Going back again, that protons are equal to electrons, so if it has 17 protons, it must have 17 electrons. And to find those neutrons, remember we're going to subtract the two, so 35 minus 17, and that is going to give me a total of 18 neutrons. So I've calculated the pin for chlorine. Moving on to chromium, again, looking at that bottom number for my protons, it is 24. Protons are equal to electrons, so I also have a 24. And to find my neutrons, I'm subtracting, so 52 minus 24 is going to give me 28. That one is done, and our last one is for cesium. So I'm looking at that atomic number of 55 for protons. Protons are equal to electrons, so I also have 55 electrons for cesium. And for my neutrons, I'm subtracting the two, so 133 minus 55 is going to give me 78 neutrons. So calculating the pin can be quite easy, just following those simple rules that I've stated. Taking it one step further, we have a gentleman here called Niels Bohr, and he came up with this idea of a Bohr model. Scientists like to name things that they discover or invent after themselves. So Mr. Bohr was, in that group. So Mr. Bohr came up with this idea that we have a nucleus, and in the nucleus are our protons and neutrons, and then we have these electron rings where our electrons are going to orbit outside of the nucleus. Now we have some rules we have to follow when drawing these Bohr models. A total of 2 electrons may fit on my first ring, 8 electrons can fit on my second ring, and 8 electrons can fit on my third ring. I must fill up those inside rings before I'm able to put any electrons on any of those outer rings. So each level has to be filled before you can go to the next level. So a couple practice problems. We're starting with lithium. Okay, so we're going to go ahead and write our symbol just like we did before. So I have my symbol Li. I'm looking for its atomic number. It is 3. And I am looking for its rounded off mass number. That comes to 7. So that goes on top. And then I'm going to calculate the pin, and I'll do this right here. So P-E-N, pin. Protons, electrons, neutrons. Lithium has an atomic number of 3, so it has 3 protons. It has since my protons and electrons are going to be equal, okay, so lithium has 3 electrons, and then I subtract 7 minus 3 and get my 4 neutrons. So I have my pin, now I need to put it into my Bohr model. Now this middle circle is going to be my nucleus. the only two things that can go in my nucleus are my protons and my neutrons. So I look here and I see that my protons, I've got 3, so I'm going to write 3p in my nucleus. And I'm going to look at my neutrons, and I've got 4 of them, so I'm going to write 4n. Okay, so I've completed that one. I've completed that one. Now I've got to look at these electrons, and I've got 3 electrons here. Remember our rule by Mr. Bohr, that 2-8-8 rule. So I'm going to start on my first ring, and I've got 3 electrons to take care of. So the maximum number of electrons that can go on this ring are 2. So I'm going to draw my 2 dots. There's 1 electron. There's 2 electrons. So my first ring is filled. I cannot put any more electrons on this ring. But remember, I've got to get to 3 electrons. So I need 1 more electron to make this Bohr model complete. So that 3rd electron is going to have to go in that 2nd ring. And there is my Bohr model for lithium. My next one for neon, okay, again, I'm writing my symbol, Ne, and it has an atomic number of 10, so that goes at the bottom. Has a mass number of 20, that goes at the top. I'm going to calculate my pen, P-E-N. Protons, I'm looking at that atomic number, it's 10. Protons and electrons are equal, so electrons must also be 10. And then remember to calculate my neutrons. I'm going to subtract the 2, so 20 minus 10 is going to give me 10. To do my Bohr model, remember inside are going to go my protons and my neutrons. So this time for neon, I've got 10 protons and I have 10 neutrons, so 10N. So those 2 are done. Check, check. So this time I'm going to look for my electrons, okay? Remember that rule, 2-8-8. So on my first ring, I can only put 2 electrons. So 1 dot, 2 dots, okay? And I've got to get to 10. So on that 2nd ring, I'm going to need all 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so when I count up my total number of electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that equals to those electrons on my pen.